What if we could redefine the way we produce, making it more efficient, cost-effective, and sustainable? Picture a world where production flows seamlessly, without interruptions. This is the reality with continuous centrifugal partition chromatography, or CPC. CPC is a liquid-liquid preparative chromatographic technique, in which separation occurs between two immiscible liquid solvent systems, acting as both the stationary and mobile phases. Separation of the injected sample is based on the sample components' varying partition coefficients between the mobile and stationary phases. Partition coefficient, CAD, is the equilibrium constant for the distribution of a compound in a two-phase system. A pattern of CPC cells, columns, are interconnected in series by ducts attached to a large rotor. This system is then filled with the liquid stationary phase, which is immobilized inside the rotor cell system by a strong centrifugal force. The other phase of the two-phase system acts as the mobile phase containing the sample to be purified. This liquid is fed under pressure into the rotor and pumped through the stationary phase in the form of tiny droplets. In liquid-liquid chromatography, we make the most of the liquid nature of the phases. By switching the roles and flow directions of these liquid phases during the separation process, known as dual mode, we can artificially extend the length of the column and thus enhance the resolving power of the CPC system. Imagine we have a mixture of compounds A and B with very similar partition coefficients, and the rotor is initially filled with a 50-50, upper and lower phase. The separation begins in ascending mode, where we pump the upper phase into the rotor's inlet. Because compound A has a lower CAD value, it moves through the system faster. We can collect a small, pure portion of compound A during this phase. However, once compound B reaches the rotor's outlet, we switch the valve to pump the lower phase in the opposite direction. This pushes the partially separated mixture of A and B back into the system. In this step, compound B becomes the faster-moving one, reciprocal CAD values govern their speeds, and we can collect pure compound B at the inlet of the rotor, while the co-elution band is pushed back. This cycle can be repeated until both compounds are fully separated using the CPC system. This technique allows us to effectively resolve compounds with very similar partition coefficients. Here's how it works. In an MDM separation, you have 4 consecutive steps: rotor fill, injection, ascendant-descendant extraction, and finally extrusion. Let's examine this example, where we want to separate two components, A and B. In the rotor fill step, we fill up the CPC rotor volume with 50% upper phase and 50% lower phase, without revving up the rotor. During injection, we inject the sample to be purified between the two CPC rotors. In the ascendant-descendant extraction step, separation of the injected sample begins. The peaks on the graph show the switching of the two modes, ascendant and descendant, at specific intervals. The injected sample is passed between the modes, so the components in the injected material start to separate from each other, which increases selectivity. Finally, in extrusion, the components can be extruded from the column as they have been separated from each other. In the graph, you can see how compounds A and B are fully separated from each other. In trapping mode, the first two steps are exactly the same as in MDM. First, you fill the rotor with 50% upper phase and 50% lower phase, without revving up the rotor. Then you inject the sample to be purified between the two CPC rotors. Differences take place in the ascendant-descendant steps, compared to MDM. In this example, we want to separate 3 components from a mixture, A, B, and C. The 3 compounds have different partition coefficients and will distribute differently between the upper and lower phases based on their partition coefficients. The compound with the lowest partition coefficient relative to the descending mode will separate in the descending mode. Then, when you switch modes, the compound with the lowest partition coefficient relative to the ascending mode will separate in the ascending mode. The third compound, which is in the middle according to its partition coefficient, will now be separated from the 2 other components. Finally, in extraction, you can eluate the component remaining in the column, and at this point, compounds A, B, and C will all be separated. In a continuous MDM mode separation, the injected components have greater selectivity than in the previous two modes, which means that the sample can be injected continuously. This means that unlike in MDM or trapping MDM, there is no separate injection step, but continuous injection is taking place instead. In the graph, you can see the complete continuous MDM purification taking place, with several ascending and descending steps. Here, you can see the highlighted blue bar in higher resolution. Compounds A and B separate according to their partition coefficients in ascending or descending mode, just like in the previously discussed modes. Injection of the compounds takes place in this highlighted section. At the end of the highlighted section, the sample injection pump stops, and the ascending-descending modes continue to switch so that the compounds can be fully separated. Continuous injection in MDM offers increased efficiency compared to batch processing, allowing you to save even more on expenses. Productivity can be increased more than threefold compared to batch processes, without any significant change taking place in solvent consumption. This allows users to have much more productivity and throughput, with operational costs and hourly solvent consumption remaining largely unchanged. The continuous CPC, when compared to simulated moving bed and multiple column chromatographic solutions, offers a significant decrease in expenses, as it requires no solid stationary phase, unlike legacy and mainstream continuous chromatographic solutions. The solvent system in the continuous CPC is also noteworthy, as it can further decrease your expenses. The platform comes with a solvent recycling system, which greatly reduces the need to spend on new solvent. Another aspect of maximizing your throughput is the footprint of the continuous CPC. Since the platform requires much less footprint than comparative solutions, the continuous CPC allows you to achieve the same throughput as other, larger footprint platforms. RotaChrom's continuous centrifugal partition chromatography platform is a continuous, multiple dual-mode, dual-rotor CPC platform. It consists of three main devices. The first are two interconnected CPC devices, which provide the core of the separation with two chromatographic columns. The second device is the preparative unit, which hosts the industrial valves and the three-membrane pump. And finally, the control unit, which is the brain of the platform, housing the HMI interface, the industrial fill buses, and the machinery safety controls. The platform is highly scalable, adaptable to various sizes and requirements, and built with robustness in mind, meeting industrial standards for durability. This device is exceptionally versatile, making it adept at handling liquid-liquid chromatography. It incorporates an on-demand solvent handling system that can be tailored to specific industrial standards. Moreover, it enhances throughput with its continuous injection mode, allowing for more efficient sample processing. RotaChrom ensures that its device complies with cleaning validation and cleaning standards in line with GMP directives. Safety is a priority, as the continuous CPC is explosion-proof, suitable for installation in rooms classified as ATEX, IECEX Zone 2. Additionally, the electrical cabinet comes pre-certified for added safety assurance. In terms of construction, all wetted components are constructed from high-quality materials like 316L, 1.4404 stainless steel or PEEK, known for their resistance to corrosion and chemical reactions. GMP compliance and automation. Compliance is another crucial aspect of any production process. With continuous CPC, you don't have to worry. The platform comes with a variety of compliance specifications and can be customized to your platform, in accordance with CGMP directives. All stainless steel wetted components are constructed from certified material for maximum durability and reliability. Finally, Continuous CPC offers a certified software solution. This custom-made software solution, designed by industry-leading engineers, comes with qualification and testing documents designed for FDA 21 CFR Part 11, GAMP 5, and EUDRALEX Volume 4, Annex 11 compliance. Contact us today to learn more about how Continuous CPC can revolutionize your production process. Experience the future of manufacturing with Continuous CPC.